Good morning, class. Today we're going to be looking more into the area model for multiplication. Let's review before we get too far. Let's see, we're going to start with this shape, and with the area model for multiplication, we're going to find out how much area this is in the middle. Really important for us, say, if you want to plant a garden, how much can I plant on the inside? So let's review with what we've already been practicing, and we're going to go with 5 times 6. So what we're going to do is, remember, it's the length times the width. So the length we're going to put on the top for 5, and the width we're putting down the side. So we could just multiply the 5 times the 6, but we're going to actually decompose those numbers. And who remembers what decompose means? Good. It's breaking down the numbers into smaller units, but when you put them back together, you're back to your original unit that you had before. So we can decompose 5 into a 2 and a 3, because when you put the 2 and 3 back together, you're going to equal 5. And then 6, we can decompose 6 into 3 and 3, because 3 plus 3 equals 6. And then what I'm going to do from here is section off our area. So now each of these numbers are going to fit into our area. I'm going to use different colors to kind of help point this out a little bit. And I'm going to use blue for the first one. So first, we're going to take this 3 multiplied by 3, follow them down. So here's 3 times 3. And what is 3 times 3? Yeah, it is 9. So before I get too far, I'm just going to write our partial products off to the side. So here we have 9. So we know this one equals 9 for 3 times 3. All right, our next unit we're going to go to is 3 times 3 up here. So they look very similar because remember these two decomposed numbers are the same. So we have a 3 times 3. And again, 3 times 3 is what? It's 9. 9 would be 3 times 3. This one is right here. All right, I'm going to use a different color now. We're going to move to the other number, which is the 2. So the 2 and the 3. So it's going to go 2 times 3 for this unit. All right, and then 2 times 3 is what? Yes, 6. Good job. 2 times 3 equals 6. And then we have one more section of this area to figure out. And again, look at the 2 and look at the 3, me in the middle. So 2 times 3, and this one's going to go right here. Again, 2 times 3, we already know is 6. Good. So now we have all of these partial products. Remember, partial products are like part of your answer. All of these together are all the different pieces for our original problem up top. So to find the full product, we have to add all of our partial products together. Drop to my pen. All right, so we're going to add these together. And you can just go down the line and add them. What I'm going to do is kind of group them together to make it the adding easier for us. So let's do 9 plus 9. 9 plus 9 is what? 18. Good. And then we're going to do the 6 plus 6. And 6 plus 6 is 12. And then we take both of those totals, add them up. 8 plus 2 is 10. Yet remember going to put the 0 down because we don't have any ones. Regroup that 10 up top. So we have 10, 20, and 30. Because remember, even though it has a 1, does it mean 1? Nope, it's in the 10 spot. So it means 10. So we're going to count them 10, 20, and 30. So now we know that 5 times 6 equals 30. Thumbs up, you guys with me still? Perfect. What I'm going to do now is I'm going to challenge us a little bit. All right. What I'm going to do now is we're going to take that same area model and we're going to decompose two-digit numbers instead of just two single numbers. Concept is still the same, but this time we are going to find out 15 times 23. 15 times 23. Remember again, this is the length and this is the width. So I'm going to start by drawing our rectangle shape right here. And I'm going to label 15. I'm going to label this one 23. And before we get too far on this one, I'm also going to write down this multiplication problem into a standard algorithm form. 15. All right. And then first thing we have to do is decompose the numbers, but we're going to decompose these numbers into our place values. So we're going to take the tens and the ones to separate those two. So 15, to decompose 15 into place values, we're going to have a 10. And then our other number for our ones is a 5. So we have 10 and a 5 for 15. For our 23, we have to decompose those into our place values also. So what number is in the ones? The 3, I love it. And what number is in the tens? 2. Is it really 2? So the 2 represents the 20 for being inside the tens place value spot. Amazing. All right. So 10 is in this unit. The 20 is inside this unit. 5 is for this unit, with the 20 also inside that unit. 5 is inside the bottom unit. This time the 3 is inside this unit. And then continuing going around, we have the 10 and the 3 in our last unit. I'm going to switch colors like I did last time to kind of help us follow along. And again, starting with the blue. If you were to start with this algorithm, 5 times 3 would be the first one. Did we see that over here? 5 and our 3, that will line up to this bottom quadrant right here. So 5 times 3 right here. So 5 times 3. What is 5 times 3? 15. Yeah. So I'm just going to add that right here. So 15. And make a note that this is our 5 times 3. Amazing. All right, next we'll do the 5. Kind of looks like the 2, but is it really just a 2? Nope, you got it. It's in the tens place value. So it's 5 times 20. I think I remember I was talking about that. So here's our 5. Where's our 20? Right here. And they meet right in this quadrant. So I'm going to write down 5 times 20. That's going to go right here. What is 5 times 20? 100. The 100 right here. And then making sure I keep the ones, the tens, and then the hundreds place value all in line. It's going to help me out a lot when I go to add all the partial products at the end. This one is a 5 times 20. All right, let me switch colors. I'm going to grab our green. All right, we finished the 5. It was 5 times 3. We have 15. 5 times 20. We have it here is 100. Now I have to move to the 1. Is it a 1? Oh, I heard someone say tens. Yep, so it's actually a 10. So this is going to be a 10 times 3 because the 3 is inside the 1. Do we see that over here? Here's our 10. Here's our 3. They line up right in this bottom section here. So you have our 10 times 3. This is going to go right here. What is 10 times 3? Absolutely, it is 30. On my note, this is our 10 times 3. And then our last section, I'll use a brown, is this 10, because we know it's in the tens area, or the tens place value, times this 2, and the 2 is also in the tens place value. So it's going to be 10 times 20. Looks like that's our biggest section right here. We have a 10, and we have our 20. Let's put them both in the middle. So 10 times 20. And now I'll go here. What is 10 times 20? I'm here, love. 200s, absolutely. So again, I'm making sure I line up my hundreds, my tens, and my ones. And this is my 10 times 20. All right, so now that we've found out all these partial products, we're done, right? Nope, you are absolutely right. Now we have to add them all together. In here, we can go right down the ones. That's a 5 plus 0 plus 0 plus 0 is 5. So the 5 stays in the ones place value. Let's move to our tens place value. So we have a 10, a 0, a 30. Remember the 3 stands for the tens place value, so 30 plus a 0. So 10 plus 30 is 40. So we added our 4 at the bottom. And then we're going to move to our hundreds place value. So it says nothing here, so it's kind of like a 0. 100, nothing here, plus 200. So 100 plus 200, 300. So what we have here is 15 times 23 equals 345. So we know all these partial products added together give us a full product of 15 times 23 equals 345. So I know it's a lot, but we've been working really hard. You guys have aced the single digits. We are really just going to focus on these two double-digit numbers, decomposing them into our place values. The place values make them very friendly and very easy numbers to manage. And I'm going to have you go to your desk and we are going to practice 18 times 25. 18 times 25. Remember, length times width. Think you're planning a garden. How much space do I have? Start off by drawing your shape, length and width. Label them both, and then you can decompose by the place values. What tens and ones make up 18? What tens and ones make up 25? All right, I'm going to stop right there. I'll be around if you have any questions. Feel free to ask me. And I can't wait to see your hard work.